Good evening. Welcome to our live stream of Nvidia's GTC 2026. I am waiting, as everyone is, for Nvidia to go live. It is not unusual for them to be very late on these things, so bear with us. I'm going to just hang about while they get a few things sorted. Was just listening in to the pregame, and it certainly looks like they were having a few audio difficulties to start with. Just trying to get our chat mode on, making sure that that works fine so that I can take any questions that anybody's got. So let's see if this is working. We haven't done a... There we go, that seems to be working fine. If you are following us, subscribing to our YouTube channel, you'll be able to ask questions. So feel free to jump into the chat box and fire anything away. While we wait for Nvidia to get their stuff together, I'll be able to answer any questions that you've got. And then I'm going to get another tab going somewhere else to see if I'm just making sure that it's not my feed that is delayed, but it seems to be not. Bear with us. Bear with Nvidia. You can be the biggest company in the world, but you can also not always run on time. Welcome as well. Anybody that is joining us to the feed, I'm seeing a few more people tick in just as the time ticks over. If you've just joined us, Nvidia drag their feet for the start of these things usually, so there's not much to comment on apart from the really nice looking logo that they've managed to put up on the screen. I wonder if it was their AI that generated that. I'm guessing it probably was. Chat. I've got chat mode going. If anybody wants to jump onto the chat and say hi so that I know that you can send chat into there, let me know. That'd be good. Let's see if their audio is going yet. No, it is not. Okay. Hey, David, Gary. Here we go. All right, cool. The chat is fired up and ready to go. Hi, guys. Thanks for reinforcing to me that I've managed to set this up properly. So it's the first time we've done a proper live stream for a while. It is an ungodly hour where I am, so I'm looking forward to what Jensen Huang is going to say and show us. I'm guessing there'll be a lot of robots. There's always a lot of robots, or at least there's always a lot of robots on a screen, and then he wheels out one robot. Maybe he'll wheel out more robots today. That would be interesting. And a new chip, a big chip, which is really just a lot of chips in a big rack made by someone else, except for the chips. That's always Nvidia. So who knows? We'll see. Anybody got any questions already? Anybody got anything, any surprising thing that they think Nvidia is going to unleash on the world? What would be the one thing you'd love to see them show us? I wonder what I would love to see them fly Jensen Huang out on an autonomous drone with a robot in the passenger seat. That would be quite something. I wonder how is this how like TV anchors like fill time when the little person in the ear says just stretch it out? Hopefully Nvidia's not like 45 minutes late. All right, well, the good news is that their live feed is showing exactly what's on my screen right now. So we are on time. They are not, which is a pain in the backside. But here we are. I would make a coffee for myself, but my kids are asleep still, so that's not happening, because I will get it in the neck if I wake up one of the kids far too early because I made a coffee. So it's water for me until everybody in the house is awake. It'd be much easier if they could have run this thing in the evening in Pacific US time. But anyway, they've got other stuff to get on with today. Well, the good news is their October 2025 keynote is alive. UK is too patient. I'm too patient, David, for Nvidia. We're all too patient for Nvidia. It is kind of fun, though, when you get to see what they do live. Well, it does bug me slightly that they can't run on time. You know, you'd think you're I don't even know what they are now. What are they? 5 trillion market cap, something like that, and you can't run a keynote on time. Come on, guys, get your act together. $4.498 trillion company, and they can't run a conference keynote on time. Yeah, all right. Have we got any audio? Still no audio from them. Still nothing from them. Nvidia. Right, let's just see if I can refresh. Well, the good news is they're playing some audio, which I think I've muted. And it's not very good audio. It's a bit like really... Well, I mean, I guess it depends on what you're into. If you're into American pop country, then I can unmute their audio. If you are not into that, then I can leave it muted. Feel free to suggest what you would like. If you would like me to unmute Nvidia's holding pattern country playlist, let me know instead of listening to me ramble on to fill time. And if you would rather me sort of filling time, or if you just want me to shut up until it starts, that's also fine. I'll almost take a vote. Can I put a poll in here? I can start a poll. Right, create poll. Should we listen to Nvidia country music, Sam ramble? Whatever wins here. Should we listen to Nvidia country music? Here we go. The alternative is me to keep sort of talking on Nvidia. Let's see if this works. Start poll. Okay, poll is running. There we go. The poll is in the chat. Oh no! Oh wow! This is good actually. Nvidia country music. The Nvidia country music is winning. Now it's not. Oh yeah, it's still winning. All right. Okay. I don't know how many people have voted, but it sounds like the country music is winning. Oh no, it's a 50-50 split now. The longer I leave this go. Remember, your alternative is just intermittent silence and me, or Nvidia's country music. I'll give you another minute to vote. Well, this is tight. Uh-oh. Oh, no. Okay. Looks like country music is winning here. All right. Country music's winning, but then I'm still going to talk over the top of it every now and then anyway. This is a moment, no better time or place. Freedom's our only focus, won't hit the brakes. We're coming now. Can't stop this feeling. I'll put it on repeat. You better believe it. Ain't going nowhere. We run away now. It's a new energy. Can't stop this feeling. I live for days like these. Consider my feelings. I've been counted out, left on red, left in doubt. Every maybe felt like never, but I kept your picture in my wallet. Folded corners, yeah, I saw it every time the world. Okay, I will note Nvidia's stock price is on the move higher in anticipation of this conference. That's interesting. I'm watching the live price chart, and literally since the start of the supposed start of what this is supposed to be, the stock prices started rising up. So what will be very interesting is watching this in conjunction with the stock price. So I'm going to leave that on my screen and show you how that goes later on. Every little scar is a reason. I'm still standing, never gonna stop trying. Friends turned strangers overnight. Dreams went quiet, lost their light, but I learned to glow in the shadow. Talk to mirrors like a coach, get back up, that's all she wrote. So I run through every high, every hollow. It's in my chest, but this fight don't accept any ending that says regret. Not yet. I'm never gonna stop trying, even when the waves keep rising. You can see the fear in my eyes, and still I'm standing. I'm never gonna stop reaching, even when my hands start bleeding. Every little scar is a reason. I'm still standing, never gonna stop trying. Everyone's suitably inspired by this wonderful American inspirational country pop music. I am. I'm buzzing off the back of it. If I fall tonight, I'll rise. All my failures on my side. Oh, hey, we could be in business here, gang. Hopefully that's not a QR code that drains your crypto wallets. God, disclaimers, hey? All right, I will actually shut up when he's talking most of the time, unless I want to say something sort of relatively important or funny. And feel free, as I said, to chip in with any questions. Well, it's a bit like COVID, watching things online together.
This is how intelligence is made. A new kind of factory. Generator of tokens. The building blocks of AI. Tokens have opened a new frontier, turning data into knowledge and drawing on all we have learned. Tokens are harnessing a new wave of clean energy. And unlocking the secrets of the stars. In virtual worlds, they help robots learn. And in the physical world, perfect. Forging new paths. And clearing the way for a bountiful harvest. In the moments that matter, tokens are already there. And in the miles between, they never stop. They work where human hands cannot. So we may all breathe easier. And the smallest hearts beat stronger. Tokens are helping us break new ground. On a scale never attempted to empower the world. So we can reach
Star Cloud 1 separation confirmed.
well beyond it. Together, we take the next great leap into a bright new future built for all mankind.
Does everyone love tokens as much as I do right now? I mean,
Is where it all
tokens.
begins.
Tokens are our future.
Welcome to the stage, Nvidia founder and CEO, Jensen Huang.
Welcome to GTC!
It's inappropriate if you're British to cheer at this point.
I just want to remind you, this is a tech conference. All these people lining up so early in the morning, all of you in here, it's great to see you. GTC. GTC, we're going to talk about technology. We're going to talk about platforms. NVIDIA has 3 platforms. You think that we mostly talk about one of them. It's related to CUDA X. Our systems is another platform. And now we have a new platform called AI Factories. We're going to talk about all of them. And most importantly, we're going to talk about ecosystems. But before I start, let me thank our pre-game show hosts. I thought they did a great job.
I think he's thanking me at that point, so I'll take that one. I'll take the credit for that one.
Capital, NVIDIA's first venture capitalist. Gavin Baker, NVIDIA's first major institutional investor. These 3 people are deep in technology, deep in what's going on, and of course, they have just a really broad reach of technology ecosystem. And then, of course, all of the VIPs that I hand-selected to join us today, all-star team. I want to thank all of you for that.
Hang on, I didn't see
I
my
also
picture
want
up
to
there.
thank all the companies that are here. NVIDIA, as you know, is a platform company. We have technology, we have our platforms, we have rich ecosystem. And today, there are probably 100% of the $100 trillion of industry here. 450 companies sponsored this event. I want to thank you. 1,000 technical sessions, 2,000 speakers. This conference is going to cover every single layer of the 5-layer cake of artificial intelligence, from land, power, and shell, the infrastructure, to chips, to the platforms, the models, and of course, the most important, and ultimately, what's going to get this industry taken off is all of the applications. What it all began here. This is the 20th anniversary of CUDA. We've been working on CUDA for 20 years.
So arguably CUDA is way more important to them than the actual hardware.
For 20 years, we've been dedicated to this architecture. This revolutionary invention, SIMT, single instruction, multi-threaded, writing scalar code could spawn off into multi-threaded application, much, much easier to program than SIMD. We recently added tiles so that we could help people program tensor cores and the structures of mathematics that are so foundational to artificial intelligence today. Thousands of tools and compilers and frameworks and libraries. In open source, there's a couple of 100,000 public projects. CUDA literally is integrated into every single ecosystem. This chart basically describes 100% of NVIDIA's strategies. You've been watching me talk about this slide from the very beginning. And ultimately, the single hardest thing to achieve is the thing on the bottom, installed base. It has taken us 20 years to now have built up hundreds of millions of GPUs and computing systems around the world that run CUDA. We are in every cloud. We're in every computer company. We serve just about every single industry. The installed base of CUDA is the reason why the flywheel is accelerating. The install base is what attracts developers, who then creates new algorithms that achieves a breakthrough. For example, deep learning. There are so many others. Those breakthroughs leads to entirely new markets, which builds new ecosystems around them with other companies that join, which creates a larger install base. This flywheel is now accelerating. The number of downloads of NVIDIA libraries is incredibly accelerating. It's at a very large scale and growing faster than ever. This flywheel is what makes this computing platform able to sustain so much applications, so many new breakthroughs, but most importantly, it also enables these infrastructures to have extraordinarily useful life. And the reason for that is very obvious. There's so many applications that you can run on NVIDIA CUDA. We support every single phase of the AI lifecycle. We address every single data processing platform. We accelerate scientific principled solvers of all different kinds. And so the application reach is so great that once you install NVIDIA GPUs, the useful life of it is incredibly high. It is also one of the reasons why Ampere, that we shipped them some 6 years ago, the pricing of Ampere in the cloud is going up. And so all of that is made possible fundamentally because the install base is high, the flywheel is high, the developer reach is great. And when all of that happens, and we continuously update our software, the computing cost declines. The combination of accelerated computing, speeding up applications tremendously. Meanwhile, as we continue to nurture and continue to update software over its life, not only do you get the first-time pop, you get the continuous cost reduction of accelerated computing over time. And we're willing to nurture, willing to support every single one of these GPUs in the world because they're all architecturally compatible. We're willing to do so because the install base is so large, if we release a new optimization, it benefits millions. This applies to everybody in the world. This combination of dynamics is what makes the NVIDIA architecture expand its reach, accelerating its growth, at the same time driving down computing cost, which ultimately encourages new growth. So CUDA is at the center of it. But our journey to CUDA actually started 25 years ago. GeForce.
Ooh, hands up if you had one of those bad boys back in the day.
GeForce is NVIDIA's greatest marketing campaign. We attract future customers starting long before you could afford to pay for it yourself. Your parents paid for you to be NVIDIA customers, and every single year they paid up year after year after year until someday you became an amazing computer scientist and became a proper customer, a proper developer. But this is the house that GeForce made. 25 years ago, we started our journey, which led to CUDA. 25 years ago, we invented the programmable shader, a perfectly unobvious invention to make an accelerator programmable, the world's first programmable accelerator, the pixel shader. 25 years ago, that led us to explore further and further. 20 years later, 5 years later, the invention of CUDA. One of the biggest investments that we made, and we couldn't afford it at the time, and it consumed the vast majority of our company's profits, was to take CUDA on the backs of GeForce to every single computer. We dedicated ourselves to create this platform because we felt so strongly about its potential. But ultimately, the company's dedication to it, despite the hardships in the beginning, believing in every single day, for 13 generations of 20 years, we now have CUDA installed everywhere. The pixel shader led to, of course, the revolution of GeForce. And then 10 years ago, we introduced, about 10 years ago, 8 years ago, we introduced RTX, a complete redesign of our architecture for the modern era of computer graphics. GeForce brought CUDA to the world. GeForce, therefore, enabled Alex Krizhevsky and Ilya Sutskever and Jeff Hinton, Andrew Ng, and so many others to discover that the GPU could be their friend in accelerating deep learning. It started the big bang of AI. 10 years ago, we decided that we would fuse programmable shading and introduce two new ideas: ray tracing, hardware ray tracing, which is incredibly hard to do, and a new idea at the time. Imagine, about 10 years ago, we thought that AI would revolutionize computer graphics. Just as GeForce brought AI to the world, AI is now going to go back and revolutionize how computer graphics is done all together. Well, today I'm going to show you something of the future. This is our next generation of graphics technology. We call it neural rendering, the fusion of 3D graphics and artificial intelligence. This is DLSS 5. Take a look at it.
So while they're going through this, I mean, I don't know if there's many gamers out there, but ray tracing made a massive difference to the gaming industry and how you view games, make them more realistic, particularly with like light shades and things like reflections off water and that sort of thing. Problem is, unless you've actually got the hardware yourself to make ray tracing work, it's kind of limited as to who actually benefits from it. So the gaming industry is pretty big on a lot of this stuff, and this is a sort of important part of their NVIDIA's core customer base. But it's not really what drives their profits as much as everything else these days. So this is all nice. This looks cool. It's like, this is the wow factor before they get into all the other stuff like data centers, which aren't quite as exciting. I mean, making a soccer player look fantastic is really cool, but it's not as much as their core business as it used to be. So this is kind of pandering to their core fans.
Is that incredible? Computer graphics comes to life. Now, what did we do? We fused controllable 3D graphics, the ground truth of virtual worlds, the structured data. Remember this word, the structured data of virtual worlds, of generated worlds. We combine 3D graphics, structured data, with generative AI, probabilistic computing. One of them is completely predictive, the other one probabilistic, yet highly realistic. We combine these two ideas, controlled through structured data, controlled perfectly, and yet generating at the same time. And as a result, the content is beautiful, amazing, as well as controllable. This concept of fusing structured information and generative AI will repeat itself in one industry after another industry after another industry. Structured data is the foundation of trustworthy AI. Well, this is going to scare you a little bit.
That was a lot of buzzwords.
And don't gasp. So we're going to go through this schematic for the rest of the time.
It doesn't look complicated at all, does it? It's quite straightforward.
This is my best slide. Every time I ask the team, what's my best slide? Repeatedly, this was it. They say, don't do it, Jensen. Don't do it. I said, no. These seats are free for some of you. So this is your price of admission. So this is structured data. You've heard of it. SQL, Spark, Pandas, Velox, some of these really, really important, very large platforms. Snowflake, Databricks, EMR, Amazon EMR, Azure.
Yeah, I've seen my 4-year-old draw less
Cloud,
complex diagrams than that.
All of these platforms are processing data frames. These data frames are giant spreadsheets, and they hold all of life's information. This is the structured data, the ground truth of business. This is the ground truth of enterprise computing. Well, now we're going to have AI use structured data, and we better accelerate the living daylights out of it. It used to be okay, and we would, of course, we would accelerate structured data so that we could do more, we could do it more cheaply, we could do it more frequently per day, and keep the company running at a much more synchronized way. However, in the future, what's going to happen is these data structures are going to be used by AI, and AI is going to be much, much faster than us. Future agents are going to use structured databases as well. And then, of course, the unstructured database, the generative database. This database represents the vast majority of the world. Vector databases, unstructured data, PDFs, videos, speeches, all of the world's information, about 90% of what's generated every single year is unstructured data. Until now, this data has been completely useless to the world. We read it, we put it into our file system, and that's it. Unfortunately, we can't
not
query
completely
it. We
useless,
can't search for it. It's hard
I'll take
to
his
do
word
that.
for it.
And the reason for that is because there's no easy indexing of unstructured data. You have to understand its meaning, its purpose. And so now we have AI do that. Just as AI was able to solve multi-modality perception and understanding, you can use that same technology, multi-modality perception and understanding, to go read a PDF, to understand its meaning. And from that meaning, embed it into a larger structure that we can search into, we can query into. Nvidia created 2 foundational libraries, just like we created RTX for 3D graphics. We created CUDA for data frames, structured data.
Sounds like he's talking about really complex Excel spreadsheets, but just really good ones.
AI data. These 2 platforms are going to be 2 of the most important platforms in the future. Super excited to see its adoption throughout the network, this complicated network of the world's data processing systems. And the reason for that is because data processing has been around a long time. And therefore, so many different companies and platforms and services, it has taken us a long time to integrate deeply into this ecosystem. I'm super proud of the work that we're doing here. And then today, we're announcing several of them. IBM, the inventor
Did
of
not have
SQL,
Nestle up there
one of the most
on my
important
bingo card.
domain-specific languages of all time, is accelerating Watson X data with CUDA. Let's take a look at it.
60 years ago, IBM introduced
Oh,
the system
I love when they pull
360,
out the old tape
the
room
first modern
computers.
platform for
That's
general
IBM
purpose
love
computing,
going to that one.
launching the
Look at
computing
how
era.
big our computers were back then.
SQL, a declarative language to query data without requiring the computer to be instructed step by step. And the data warehouse, each the foundations of modern enterprise computing. Today, IBM and Nvidia are reinventing data processing for the era of AI by accelerating IBM Watson X.Data SQL engines with Nvidia GPU computing libraries. Data is the ground truth that gives AI context and meaning. AI needs rapid access to massive data sets. Today's CPU data processing systems can't keep up. Nestle makes thousands of supply chain decisions every day. Their order-to-cash data mart aggregates every supply, order, and delivery event across global operations in 185 countries. On CPUs, Nestle refreshed the data mart a few times a day. With accelerated Watson X.Data running on Nvidia GPUs, Nestle can run the same workload 5 times faster at 83% lower cost. The next computing platform has arrived, accelerated computing for the era of AI.
NVIDIA accelerates data processing in the cloud. We also accelerate data processing on-prem. As you know, Dell is the world-leading computer systems maker, and they also are one of the world's leading storage providers. And they worked with us to create the Dell AI data platform that integrates cuDF and cuVS to create an accelerated data platform, well, for the era of AI. And this is an example of what they did. This is cloud, Google Cloud, and Google Cloud, as you know.
Looking at the stock price, the market enjoyed the ray tracing stuff, the DLSS5 stuff, and not such a fan of the Nestle and IBM stuff. Anyway.
Together with Snapchat, where we reduced their cost of computing by nearly 80%. When you accelerate data processing, when you accelerate computing, you get the benefit of speed, you get the benefit of scale, but most importantly, you also get the benefit of cost. And so all of those come together as one. It was originally called Moore's Law. Moore's Law was about getting performance doubling every couple of years. It's another way of
Huang's
saying,
Law now, maybe?
so long as the price remains about the same, and most computers remained about the same, you're also getting twice the performance every year, or you're reducing the cost of computing every single year. Well, Moore's Law has run out of steam. We need a new approach. Accelerated computing allows us to take these giant leaps forward. And as you will see later, because we continue to optimize the algorithms, and NVIDIA is an algorithm company, as we continue to optimize the algorithms, and because our reach is so large and our install base is so large, we can reduce the computing cost, increasing the scale, increasing the speed for everybody continuously. This is Google Cloud. You could see this pattern I just mentioned. I just wanted to show you 3 versions of it. NVIDIA built the accelerated computing platform. Has a bunch of libraries on top. I gave you 3 examples. RTX is one of them, cuDF is another,
Algorithm company,
cuVS,
are they?
and
Really?
I'll show you a few more. These libraries sit on top of our platform. But ultimately, we integrate into the world's cloud services, into the world's OEMs, and together, and other platforms that I'll show you, together, we're able to reach the world. This pattern, NVIDIA, Google Cloud, Snapchat, will repeat over and over again, and it kind of looks like this. And so this is one example, NVIDIA with Google Cloud. We accelerate Vertex AI. We accelerate BigQuery. I'm super proud of the work that we've done with JAX and XLA. We're incredible on PyTorch. We're the only accelerator in the world that's incredible on PyTorch and incredible on JAX and XLA. And the customers that we support, the Base 10s, the CrowdStrikes, Puma, Salesforce, they're not our customers, but they're customers, developers of ours that we've integrated the NVIDIA technologies into that we can then land on the clouds. Our relationship with cloud service providers are essentially us bringing customers to them. We integrate our libraries, we accelerate workloads, and we land those customers in the clouds. And so, as you could see, most of our cloud service providers love working with us.
It's all very me at the moment,
they're
isn't
always
it?
asking us to land the
We
next
bring you the
customer on their
customers.
cloud. And I just want to let you know, there are a lot of customers. We're going to accelerate everybody. And so there'll be lots and lots of customers.
I feel
who will land on your
accelerated.
cloud.
Do you feel
Just be
accelerated?
patient with
I
us.
feel accelerated.
And so this is Google
Are they going to
Cloud.
accelerate us?
This is
I think so,
AWS.
maybe.
We've been working with AWS a long time. And one of the areas, one of the things I'm super excited about this year is we're going to bring OpenAI to AWS. And so it's going to drive enormous consumption of cloud computing at AWS. It's going to expand the reach and expand the compute of OpenAI. And as you know, they are completely compute constrained. And so AWS, we accelerate EMR, we accelerate SageMaker, we accelerate Bedrock. NVIDIA's integrated really deeply into AWS. They were our first cloud partner. Microsoft Azure. NVIDIA's A100 supercomputer was the first one we built was for NVIDIA. The first one we installed was at Azure. And that led to the big successful partnership with OpenAI. But we've been working with Azure for quite a long time.
Hello, Howard. Welcome to the stream,
Azure
to
Cloud.
the chat.
Now it's,
I am
their
taking
AI
questions
Foundry
whenever
we
anyone
partner
has them,
deeply with.
and
We
sometimes
accelerate
talking
Bing
over
search.
Jensen Huang.
We work with them on Azure regions. This is one of the areas that is incredibly important. As we continue to expand AI throughout the world, one of the capabilities that we offer is confidential computing. That in confidential computing, you want to make sure that even the operator cannot see your data. Even the operator cannot touch or see your models. Confidential computing, NVIDIA's GPUs is the first ones in the world to do that. It's now able to support confidential computing and protected deployment of these very valuable OpenAI models and Anthropic models throughout clouds and different regions, and all because of our confidential computing. Confidential computing is super important. And here's an example where we have different customers that we work with. Synopsys, a great partner of ours, we're accelerating all of their EDA and CAE workflows. And then we landed at Microsoft Azure. We were Oracle's first AI customer. Most people would have thought we were their first supplier. We were their first supplier also, but we were their first AI customer. I'm quite proud of the fact that I explained AI clouds to Oracle for the first time, and we were their first customer. Since then, they've really taken off. We've landed a whole bunch of our partners there, Cohere and Fireworks, and of course, very famously, OpenAI. A great partnership with CoreWeave. They're the world's first AI native cloud, a company that was built with only one singular purpose: to provision, to host GPUs as the era of accelerated computing showed up, and to host for AI clouds. They've got some fantastic customers, and they're growing incredibly. One of the platforms that I'm quite excited about is Palantir and Dell. The three of our companies have made it possible to stand up a brand new type of AI platform, the Palantir Ontology platform, an AI platform. And we could stand up these platforms in any country, in any air-gapped region, completely on-prem, completely on-site, completely in the field. AI could be deployed literally everywhere. Without our confidential computing capability, without our ability to build the end-to-end system, as well as offer the entire accelerated computing and AI stack, from data processing, whether it's vectors or structures, all the way to AI, it wouldn't have been possible. I wanted to show you these examples. This is our special working relationship with the world's cloud service providers. And all
the
of them
Department
are
of War, it looks like.
And I get the benefit of seeing them during booth tour, and it's just so incredibly exciting. I just want to thank all of you for the hard work. What NVIDIA has done is this, and you're going to see this theme over and over again. NVIDIA is vertically integrated, the world's first vertically integrated but horizontally open company. And the reason that's necessary is very simple. Accelerated computing is not a chip problem. Accelerated computing is not a systems problem. Accelerated computing has a missing word. We just never say it anymore. Application acceleration. If I could make a computer run everything faster, that's called a CPU. But that's run out of steam. The only way for us to accelerate applications going forward and continue to bring tremendous speed up, tremendous cost reduction, is through application or domain-specific acceleration. I dropped that phrase in the front, and therefore it just became accelerated computing. And that is the reason why NVIDIA has to be library after library, domain after domain, vertical after vertical. We are a vertically integrated computing company. There is no other way. We have to understand the applications. We have to understand the domain.
He's a good salesman too, isn't he? There's no other way.
And
Don't look anywhere else. No one else.
Deploy
AMD.
the algorithm
Just NVIDIA.
in whatever scenario it wants to be deployed, whether it's a data center, cloud, on-prem, at the edge, or in a robotic system. All of those computing systems are different. And finally, the systems and chips. We are vertically integrated. What makes it incredibly powerful, and the reason why you saw all the slides, is because NVIDIA is horizontally open. We'll work and integrate NVIDIA's technology into whatever platform you would like us to integrate into. We offer you the software, we offer you libraries, we integrate with your technology so that we can bring accelerated computing to everybody in the world. Well, this GTC is really a great demonstration of that. You know, most of the time you'll see me talk about these verticals, and I'll use some examples. But in every single case, whether it's automotive, by the way, financial services, the largest percentage of attendees at this GTC is from the financial services industry. I know. I'm hoping it's developers, not traders. Guys. Here's one thing I wanted to say.
Definitely traders, definitely.
In the audience represents NVIDIA's ecosystem upstream of our supply chain and downstream of our supply chain. And we think about our supply chain upstream and downstream. And it's just so exciting that our entire upstream supply chain this last year, irrespective of whether you're a 50-year-old company, we have 70-year-old companies, we have a 150-year-old company who are now part of NVIDIA's supply chain and partnering with us either upstream or downstream. And last year, you had your record year. Did you not? Congratulations.
Feels like he's just filling time now.
This is the beginning of something very,
Did he
very
lose
big.
his auto cue, I reckon?
If you look at accelerated computing, we've now set the computing platform, but in order for us to activate those computing platforms, we need to have domain-specific libraries that solve very important problems in each one of the verticals that we address. You see us addressing every single one of this. Autonomous vehicles, our reach, our breadth, our impact, incredible. We have a track on that. Financial services, I just mentioned. Algorithmic trading is going from classical machine learning with human featured engineering called the quants did that, to now supercomputers studying massive amounts of data, discovering insight and discovering patterns by itself. And so this is going through its deep learning and its transformer moment. Healthcare is going through their ChatGPT moment. Some really exciting work that we're there. We have a great keynote track here. We have a great keynote track. Kimberly Powell's doing a great keynote track for healthcare. We're talking about AI physics or AI biology for drug discovery, AI agents for customer service and support of diagnosis. And of course, physical AI, robotic systems. All these different vectors of AI have different platforms that NVIDIA provides. Industrial, we are completely resetting and starting the largest build-out of human history. And most of the world's industries, building AI factories, building chip plants, building computer plants are represented here today. Media and entertainment, gaming, of course, real-time AI platform so that we could translation and broadcast support and live games and live video. Enormous amount of it will be augmented with AI. We have a platform called Holoscan. Quantum, there are 35 different companies here building with us the next generation of quantum GPU hybrid systems. Retail and CPG, using Nvidia for supply chain, creating agentic shopping systems, AI agents for customer support. A lot of work being done here.
Be interesting to see what he says about quantum. When he's positive about quantum computing, the stocks in that sector tend to rip. If that's the extent of what he says about quantum, then it'll be interesting to see their behavior over the next day or two.
Working with literally every single company that we know of building robots. We have 110 robots here at the show. And then telecommunications. About as large as the world's IT industry, about $2 trillion. We see, of course, base stations everywhere. It's one of the world's infrastructures. It was the infrastructure of the last generation of computing. That infrastructure is going to get completely reinvented. And the reason for that is very simple. That base station, it does one thing, which is base station, is going to be an AI infrastructure platform in the future. AI will run at the edge. And so lots of great discussion there. And our platform there is called Aerial, or AI RAN. Big partnership with Nokia, big partnership with T-Mobile, and many others. At the core of our business, everything that I just mentioned.
Yes, Nokia still exists as a company, for anyone that didn't know. Getting into AI infrastructure and data center stuff more and more.
Libraries is the algorithms that NVIDIA invents. We are an algorithm company. That's what makes us special. That's what makes it possible for me to be able to go into every single one of these industries, imagine the future, and have the world's best computer scientists describe and solve problems, refactor it, re-express it, and turn it into a library. We have so many. I think we have, at this show, we're announcing 100 libraries, 70 libraries, maybe 40 models. And that's just at the show. We're updating these all the time. We're updating them all the time. The libraries is the crown jewels of our company. It is what makes it possible for that platform, the computing platform, to be activated in service of solving a problem, making impact. One of the most important libraries that we ever created, CUDNN, CUDA Deep Neural Networks. It completely revolutionized artificial intelligence, caused the big bang of modern AI. Let me show you a short video about CUDA-X.
20 years ago, we built CUDA, a single architecture for accelerated computing. Today, we've reinvented computing. 1,000 CUDA-X libraries help developers make breakthroughs in every field of science and engineering. cuOpt for decision optimization. cuLitho for computational lithography. cuDSS for direct sparse solvers. cuEquivariance for geometry-aware neural networks. Aerial for AI RAN.
So while they're going through this is kind of my point about CUDA being as important to them and the success of NVIDIA, almost more than the hardware. If NVIDIA had never built and deployed CUDA, they'd just be a really good chip maker. But because they've got the whole platform, they've got the whole ecosystem, they've got the whole developer process, that's what makes them super valuable. They've basically just locked down development for the world. No one else does it like they do. No one. Plenty of chips can get built that will be up there with theirs, but it's CUDA that makes them so valuable. So again, I might as well jump in here because no one else is talking. This is all just good looking. This is like a cutscene on a video game. Again, if you're a gamer, you'll kind of get what I mean. It's like you go around, you play the game, and then you go through this 5-minute long cutscene where you kind of sit back and go, "This is like watching a movie." And this is also a good chance for him to catch up, get a drink, maybe go to the toilet, and do all those sorts of things. So this is a hallmark of Nvidia's GTCs, where they'll show you all the stuff that is maybe coming, hopefully coming, interesting. I mean, the idea of these sorts of robotics running around, welding bridges and stuff, it's going to come. But at the same time, there's a train station getting built near me, and there's not a single robot on site. So the usual speed humps and roadblocks for those sorts of things still exist, namely around regulation, workplace health and safety. These things are going to be tested, tried, pass all those kinds of things to ensure that a robot doesn't go AWOL and fly kick a construction manager in the head and kill him. So the technology is always kind of there, just whether it actually gets deployed into the real world is another thing. But the autonomous driving is an interesting one because that is something we're seeing deploy more and more. So, it's not like these things don't find their way into the market. They just take a little bit of time.
Everything you saw was a simulation. Some of it was principle solvers, fundamental physics solvers. Some of it was AI surrogates, AI physical models. And some of it was physical AI robotics models. Everything was simulated. Nothing was animated. Nothing was articulated. Everything was completely simulated. That is what fundamentally NVIDIA does. It is through
it was animated, but
connection
semantics,
of understanding of the algorithms with our computing platforms that we're able to open up to unlock these opportunities. NVIDIA is a vertically integrated computing company with open horizontal integration with the world. So that's CUDA X. Well,
a lot of buzzwords again.
Companies. You saw Walmart and there's L'Oreal and incredible companies, established companies, JP Morgan and Roche, and these are companies that have defined society to today. Toyota is here. These are some of the largest companies in the world. It is also true that there's a whole bunch of companies you've never heard of. These are companies, we call them AI natives. A whole bunch of small companies. The list is gigantic. I couldn't. This is just a little tiny bit of it, and I couldn't decide whether to show you more or show you less, and so I made it so that you couldn't see any.
Yeah, he's right. I can't see any of those.
And nobody's feelings are hurt.
I can see a couple.
However, inside this list are a bunch of brand new companies.
DeepSeek is the one that I can see.
You might have heard a couple of them: OpenAI, Anthropic, but there's a whole bunch of others. And they serve different verticals. Something happened in the last 2 years, particularly this last year.
China's vertical.
We've been working with the AI natives for a long time, and this last year, it just skyrocketed. I'll explain to you why it happened. This industry has skyrocketed. $150 billion of investment into venture investment, into startups, the largest in human history. This is also the first time that the scale of the investments went from millions of dollars, tens of millions of dollars, to hundreds of millions of dollars and billions of dollars. And the reason for that is this is the first time in history that every single one of these companies needs compute, and lots of it. They need tokens, lots and lots of it. They're either going to create, build, and create tokens and generate tokens, or they're going to integrate, add value to tokens that are available, created by Anthropic and OpenAI and others. And so this industry is different in so many different ways, but the one thing that is very clear, the impact that they're making, the incredible value that they're delivering already is quite tangible. AI natives, all because we reinvented computing. Just like during the PC revolution, a whole bunch of new companies were created, just as just as during the internet revolution, a whole bunch of companies were created, a mobile cloud, a whole bunch of companies were created. Each one of them had their own standards, and we're talking about one of the major standards that just happened, incredibly important. And this generation, we also have our own large number of very, very special companies. We reinvented computing. It stands to reason there's going to be a whole new crop of really important companies, consequential companies for the future of the world. The Googles, the Amazons, the Metas, consequential companies that have come as a result of the last computing platform shift. We are now at the beginning of a new platform shift. But what happened in the last couple of years? Well, we've been watching, as you know, we've been working on deep learning and working on AI. The big bang of modern AI, we were right there at the spot, and we've been advancing this field for quite some time. But why the last 2 years? What happened in the last 2 years? Well, 3 things. ChatGPT, of course, started the generative AI era. It's able to not just understand, perceive and understand, it's able to also translate and generate, generation of unique content. I showed you the fusion of generative AI with computer graphics, and it brought computer graphics to life.
Tokens, tokens,
You
tokens.
guys, everybody in the world should be using ChatGPT. I know I use it every single morning, used it plenty this morning. And so ChatGPT was the generative AI era. The second, by the way, generative computing versus the way we used to do computing, it's generative AI is a capability of software, but it has profoundly changed how computing is done. Computing used to be retrieval-based, now it's generative. Keep that thought in mind when I talk about certain things, and you'll realize why it is that everything that we do is going to change how computers are architected, how computers are provided, how computers are going to be built out, and what is the meaning of computing altogether.
That's an important point.
AI,
Do remember that,
2023,
actually.
end of 22, 2023. The next, reasoning AI, 01, and then took off with 03. Reasoning allowed it to reflect, allows it to think to itself, allowed it to plan, break.
Actually, I'm just going to cut him off very quickly here. So Perplexity has already started shipping a AI native computer. It's a Mac Mini to start with, but the way in which the idea of a PC is built and sold, that is changing very, very quickly. That becomes opportunities for maybe companies like Apple to go, we can do our Macs a little differently here. So this is sort of an important aspect of how computers are going to be built.
You know, of course, you could have much larger models. The model 01 was a little bit larger, not much larger, but its input token usage for context and its output token for thinking increased the amount of computation tremendously. Then came Claude Code, the first agentic model. It was able to read files, code, compile it, test it, evaluate it, go back and iterate on it. Claude Code has revolutionized software engineering, as all of you know. 100% of Nvidia is using a combination of, or oftentimes all 3 of them, Claude Code, Codex, and Cursor, all over Nvidia. There's not one software engineer today who is not assisted by one or many AI agents helping them code. Claude Code completely revolutionizes the new inflection. And for the first time, you don't ask an AI what, where, when, how.
If you haven't used Claude Code yet,
it,
do yourself a favor.
Create,
get the Anthropic web app or the browser extension or the computer application. Have a play around with Claude Code. You will see what he means by inflection point. You can make anything you ask it to, and that is not an understatement.
Tasks. An AI that was able to perceive became an AI that could generate. An AI that could generate became an AI that could reason. An AI that could reason now became an AI that can actually do work, very productive work. The amount of computation in the last 2 years, we know that everybody in this room knows the computing demand for NVIDIA GPU is off the charts. Spot pricing is skyrocketing. You couldn't find a GPU if you tried, and yet, in the meantime, we're shipping GPUs out. Incredible amounts of it. And demand just keeps on going up. There's a reason for that. This fundamental inflection. Finally, AI is able to do productive work, and therefore, the inflection point of inference has arrived. AI now has to think. In order to think, it has to inference. AI now has to do. In order to do, it has to inference. AI has to read. In order to do so, it has to inference. It has to reason. It has to inference. Every part of AI.
Yes, I'm going to just cut him off again here. Inference is something you will have seen me write about a lot over the last however many months. This is the next shift, right? From data retrieval to proper thinking, reasoning, rational processes. Inference and inference chip making is big. This is big for Nvidia as well.
Necessary, increased by roughly 10,000 times. Now, when I combine these two, the fact that since in the last 2 years, the computing demand of the work has gone up by 10,000 times. And the amount of usage has probably gone up by 100 times.
Could someone teleport me a coffee, please?
Computing demand has increased by 1 million times in the last 2 years. It is the feeling that we all have. It is the feeling every startup has. It's the feeling that OpenAI has. It's the feeling that Anthropic has. If they could just get more capacity, they could generate more tokens. Their revenues would go up. More people could use it. The more advanced, the smarter the AI could become. We are now at that positive flywheel system. We have reached that
the
moment.
flywheel.
The inflection, the inference inflection has arrived. Last year, at this time, I said that where I stood at that moment in time, we saw about $500 billion. We saw $500 billion of very high confidence demand and purchase orders for Blackwell and Rubin through 2026. I said that last year. Now, I don't know if you guys feel the same way, but $500 billion is an enormous amount of revenue. Not one impressed.
Say trillion. Say trillion. Do it. Look at the stock. You should see the stock price right now. It just green candle lit up.
I know why you're not impressed,
And
because
it's
all
still
of you
going.
had record years. Well, I'm here to tell you that right now where I stand,
Watch the stock. The stock price is going
a few
bonkers
short
right now.
months after GTC DC, 1 year after
God.
last GTC, right here where I stand, I see
He's going to say trillion.
through 2027
He's going to say trillion.
at least $1 trillion.
You should see the stock price. This is mental. Honestly, the stock price has gone vertical.
Now, does it make any sense? And that's what I'm going to spend the rest of the time talking about. In fact, we are going to be short. I am certain computing demand will be much higher than that. And there's a reason for that. So the first thing is, we did a lot of work in the last year. Of course, as you know, 2025 was NVIDIA's year of inference. We wanted to make sure that not only were we good at training and post-training, that we were incredibly good at every single phase of AI, so that the investments that were made, investments made in our infrastructure, could scale out for as long as they would like to use it. And the useful life of NVIDIA's infrastructure would be long, and therefore the cost would be incredibly low.
Look at that CUDA
The
percentage
longer you
again.
can use it, the lower the
CUDA.
cost. There's no
Without
question
CUDA,
in my mind.
they're
NVIDIA systems are the lowest cost infrastructure
third
you could get
of the
for
size they
AI
are.
infrastructure in the world. And so the first part was, last year was all about AI for inference, and it drove this inflection point. Simultaneously, we were very pleased last year that Anthropic has come to NVIDIA, that MSL, Meta SL, has chosen NVIDIA. And meanwhile, and as a collection, as a group, this represents 1/3 of the world's AI compute, open source models. Open source models have reached near the frontier, and it is literally everywhere. And NVIDIA, as you know, today, we're the only platform in the world today that runs every single domain of AI across every single one of these AI models in language and biology, in computer graphics, computer vision, in speech, proteins and chemicals, robotics and otherwise, edge or cloud, any language. NVIDIA's architecture is fungible for all of that, and we're incredible for all of that. That allows us to be the lowest cost, the highest confidence platform. Because when you're building these systems, as I mentioned, $1 trillion is an enormous amount of infrastructure. You have to have complete confidence that the $1 trillion you're putting down will be utilized, would be performant, would be incredibly cost-effective, and have useful life for as long as you could see. That infrastructure investment you could make on NVIDIA, you could make with complete confidence. We have now proven that. It is the only infrastructure in the world that you could go anywhere in the world and build with complete confidence. You want to put it in any of the clouds, we're delighted by that. You want to put it on-prem, we're happy about that. You want to put it in any country, anywhere, we're delighted to support you. We are now
Any
a
country?
platform
Sure about that?
runs all of AI. Now, our business already
China's
starting
like,
to show that.
yes, get in.
60% of our business is hyperscalers, the top 5 hyperscalers. However, even within that top 5 hyperscalers, some of it is internal AI consumption. The internal AI consumption, really important work, like Rexus is moving from recommender systems.
He needs to talk about trillions again because the after the stock price went vertical, it's come back down again.
Search.
Say trillions. Say
Large
trillions.
language models. Almost all of these different hyperscale workloads are now moving, shifting towards a workload that NVIDIA GPUs are incredibly good at. But on top of that, because we work with every AI lab, because we work with every AI, we accelerate every AI model, and because we have a large ecosystem of AI natives that we work with that we can bring to the clouds, that investment, no matter how large, no matter how quick, that compute will be consumed. And that represents 60% of our business. The other 40% is just everywhere. Regional clouds, sovereign
When he says
clouds,
trillions,
enterprise,
market
industrial,
price goes up.
robotics, edge,
When he stops saying trillions,
big systems, supercomputing systems, small servers,
market price goes
enterprise
down.
servers. The number of systems, incredible. The diversity of AI is also its resilience. The span of reach of AI is its resilience. There is no question this is not a one-app technology. This is now fundamental. This is absolutely a new computing platform shift. Well, our job is to continue to advance the technology, and one of the most important things that I mentioned last year was our year of inference. We dedicated everything. We took a giant chance and reinvented while Hopper was
spent $20
at its
billion
prime,
on
and it was
Grock,
just
an
cooking.
inference chip maker
We
as well.
decided that the Hopper architecture, the NVLink by 8, had to be taken to the next level. We completely re-architected the system, disaggregated the computing system altogether,
Although that
and
was
created
this year.
NVLink 72. The way that it's built, the way it's manufactured, the way it's programmed, completely changed. Grace Blackwell NVLink 72 was a giant bet. And it wasn't easy for anybody. And many of my partners here in the room, I want to thank all of you for the hard work that you guys did. Thank you.
Inference, inference, inference. They're going to keep going with this.
NVLink 72, NVFP4, not just FP4 precision. FP4 is a whole different type of tensor core and computational unit. We've demonstrated now that we can inference NVFP4 without loss of precision, but gigantic boost in performance and energy efficiency. We've also been able to use NVFP4 for training. So NVLink 72, NVFP4, the invention of Dynamo, TensorRT LLM, a whole bunch of new algorithms. We even built a supercomputer to help us optimize kernels and help us optimize our complete stack. We call it DGX Cloud. We invested billions of dollars of supercomputing capability, help us create the kernels, the software that made inference possible. Well, the results all came together.
Drum roll.
And people used to tell me, but Jensen, inference is so easy. Inference is the ultimate hard. Inference is ultimate hard. It is also ultimate important because it drives your revenues. And so this is the outcome. This is from semi-analysis. This is the largest, most comprehensive sweep of AI inference that has ever been done. And what you see here on the left, on this side, is tokens per watt. Tokens per watt is important because every data center, every single factory, by definition, is power constrained. A 1 gigawatt factory will never become 2. It's physically constrained. The laws of atoms, the laws of physicality. And so that 1 gigawatt of data center, you want to drive the maximum number of tokens, which is the production, the product of that factory. So you want to be on top of that curve as high as you want. The x-axis is the interactivity, the speed of inference, the speed of each inference. The faster you can inference, the faster you could, of course, respond. But very importantly, the faster you can inference, the larger the models, the more context you could process, the more tokens you can think through. This axis is the same as smartness of the AI. And so this is the throughput of the AI. This is the smartness of the AI. Notice, the smarter the AI, the lower your throughput. Makes sense. You're thinking longer. Okay? And so this axis is the speed, and I'm going to come back to this. This is important. This is where I torture all of you. But it's too important. Every CEO in the world, you watch, every CEO in the world will study their business from now on in the way I'm about to describe.
Yeah, that x-axis only goes to 200. Tokens per
token
second
factory.
should be into the thousands for inference.
AI factory, this is your revenues. There's no question about that going forward. And so this is the throughput, this is the intelligence. Better perf per watt for a given power of data center, the more throughput, the more tokens you could produce. On this side is cost. Notice, Nvidia is the highest performance in the world. Nobody would be surprised by that. They would be surprised by the fact that in one generation, whereas Moore's law would have given us, through transistors, 50%, 2 times, Moore's law would probably give us 1.5 times more performance. You would have expected from Hopper H200, 1.5 times higher. Nobody would have expected 35 times higher. I said last year at this time that NVIDIA's Grace Blackwell NVLink 72 was 35 times perf per watt. Nobody believed me. And then semi-analysis came out, and Dylan Patel had a quote. He accused me of sandbagging. He accused me of sandbagging. He says, Jensen sandbagged. It's actually 50 times. And he's not wrong. He's not wrong. And so our cost per token. Yeah.
I look forward to social media picking apart these
Our
these
cost
charts.
per token is the lowest in the world. You can't beat it. I've said before, if you have the wrong architecture, even if it's free, it's not cheap enough. And the reason for that is because no matter what happens, you still have to build a gigawatt data center. You still have to build a gigawatt factory, and that gigawatt factory, for 15 years amortized across, that gigawatt factory is about $40 billion. Even when you put nothing on it, it's $40 billion in. You better make for darn sure you put the best computer system on that thing so that you could have the best token cost. NVIDIA's token cost is world-class.
Jensen, the salesman's back.
Basically untouchable at the moment. And the reason that's true is because of extreme co-design. And so I'm very happy that he named us
Also interesting about the model they used. It looked like down in the disclaimer down the bottom there, it was a DeepSeek model. Run those over a whole bunch of other different AI models, and it'll be interesting to see what the cost is. I imagine it's still very good, but you know,
Token King.
it's a select pool of analysis.
Well, we take all of our software, as I told you, we vertically integrate, but we horizontally open. We're vertical integration, horizontal open. We integrate all of our software and all of our technology, however we could package it up and integrate it into the world's inference service providers. And these companies are growing so fast. They're growing so fast. Fireworks.
The stock price has also erased all of those gains from when he said trillions.
100 times in the
Definitely
last year.
traders in the room.
They are token factories. And the effectiveness, the performance, and the token cost production capability for their factories is everything to them. And this is what happened. We updated their software, same system, and notice their token speeds, incredible. The difference before Nvidia updated everything and all of our algorithms and software,
tokens per second, for proper inference, tokens per second should be up into the thousands. So they're making big leaps and strides, but not as big as I probably thought they might have been announcing.
Extreme co-design. I mentioned earlier the importance of factories. This is the importance of factory. Your data center, it used to be a data center for files. It's now a factory to generate tokens. Your factory is limited no matter what.
Tokens. Back to tokens.
Once you build it, you are power limited. Within that power limited infrastructure, you better make for darn sure that your inference, because you know inference is your workload and tokens is your new commodity, that compute is your revenues, that you want to make sure that the architecture is as optimized as you can. In the future, every single CSP, every single computer company, every single cloud company, every single AI company, every single company, period, are going to be thinking about their token factory effectiveness. This is your factory in the future. And the reason why I know that is because everybody in this room is powered by intelligence. And in the future, that intelligence will be augmented by tokens. So let me show you.
Is he talking about tokens in my brain? Am I going to be? Are we going to be powered by tokens?
2016, a decade ago, we introduced DGX-1, the world's first computer designed for deep learning. 8 Pascal GPUs connected with the first generation NVLink. 170 teraflops in one computer, the world's first computer designed for AI researchers. With Volta, we introduced NVLink Switch. 16 GPUs connected with full all-to-all bandwidth, operating as one giant
Just give
GPU.
us DGX Spark, the desktop version
but model
of this,
sizes
please.
continued to grow. The data center needed to become a single unit of computing, so Mellanox joined Nvidia. In 2020, DGX A100 SuperPod became the first GPU supercomputer combining scale-up and scale-out architecture. NVLink 3 for scale-up, Connect X6, and Quantum InfiniBand for scale-out. Then Hopper, the first GPU with the FP8 transformer engine that launched the generative AI era. NVLink 4, Connect X7, Bluefield 3 DPUs, second generation Quantum InfiniBand. It revolutionized computing. Blackwell redefined AI supercomputing system architecture with NVLink 72. 72 GPUs connected by NVLink Spine. 130 terabytes per second of all-to-all bandwidth. Compute trays integrate Blackwell GPUs, Grace CPUs, Connect X8, and Bluefield 3. Scale-out runs over Spectrum 4 Ethernet. With 3 scaling laws in full steam, pre-training, post-training, and inference, and now agentic systems, compute demand continues to grow exponentially. And now, Vera Rubin. architected for every phase of agentic
That's
AI.
a heck of a lot of server
Advancing every
racking.
pillar of computing, including CPU, storage, networking, and security. Vera Rubin NVLink 72, 3.6 exaflops of compute, 260
Williams did the score
terabytes
for
per
this?
second of all-to-all NVLink bandwidth. The engine supercharging the era of agentic AI, the Vera CPU rack, designed for orchestration and agentic workflows. The STX rack,
John Williams.
AI native
I think
storage
it's Williams.
built with Bluefield 4. Scale out with Spectrum X co-packaged optics, increasing energy efficiency and resiliency. And an incredible new addition,
Stock
the
price
Grock
is
3
bored of this now.
LPX rack. Tightly connected to Vera Rubin, Grock's LPU's massive on-chip SRAM, a token accelerator to the already incredibly fast Vera Rubin. Together, 35 times more throughput
Ah,
per
there's the
megabyte.
Grock chip.
The new Vera Rubin platform. 7 chips, 5 rack-scale computers, 1 revolutionary AI supercomputer for agentic AI. 40 million times more compute in just 10 years.
Nothing groundbreakingly new so far that wasn't
Now,
expected.
in the good old days, when I would say Hopper, I would hold up a chip. That's just adorable. This is Vera Rubin. When we think when we think Vera Rubin, we think the entire system. Vertically integrated completely with software. Extended end to end. Optimized as one giant system. The reason why it's designed for agentic systems is very clear, because agents, of course, the most important workload is it's thinking the large language model. The large language models are going to get larger and larger and larger. It's going to generate more and more tokens more quickly so it can think more quickly, but it also has to access memory. It's going to pound on memory really hard. KV cache,
Ooh, here we
structured
go.
data,
Talk about
QVF,
memory.
unstructured data, QVS. It's going to be pounding on the storage system really, really hard, which is the reason why we reinvented the storage system. But it's
Of course
also
they did.
going to use tools. And unlike humans that are more tolerant to slower computers, AI wants the tools to be as fast as possible. These tools, web browsers, in the future, they could also be virtual PCs in the cloud. Those PCs have to be, and those computers have to be as fast as possible. We created a brand new CPU that's designed for extremely high single-threaded performance, incredibly high data output, incredibly good at data processing, and extreme energy efficiency. It is the only data center
Let's see
CPU
how
in the world
Intel's stock
that
reacts to
uses
this.
LPDDR5, and incredible single-thread performance and performance per watt that is unrivaled. And so we built that so that it could go along with the rest of these racks for agentic processing. And so here it is. This is the Grace Blackwell, Vera Rubin, where is it? Here it is, okay? So this is the Vera Rubin system.
It's like he's
Notice since the
introducing
last
his
time,
children.
100% liquid
Sweet.
cooled. All of the cables gone. What used to take 2 days to install now takes 2 hours. Incredible. And so the manufacturing cycle time is going to dramatically reduce. This is also a supercomputer that is cooled by hot water, 45 degrees, which takes the pressure off of the data center, takes all of that cost and all of that energy that's used to cool the data center.
That's probably
and makes
the
it available
super
for
microcomputer
the
hot
system.
water cooling stuff.
This is the secret sauce. We're the only company in the world that has today built the sixth generation scale-up switching system. This is not Ethernet. This is not InfiniBand. This is NVLink. This is the 6th generation NVLink. This is insanely hard to do well. It is insanely hard to do, period. And I'm just super proud of the team. NVLink, completely liquid cooled. This is the brand new Grock system, and I'll show you a little bit more about it. This system, 8 Grock chips.
This is what
This
$20
is the
billion
LP30.
gets you.
The world's never seen it. Anything that the world's ever seen is V1. This is 3rd generation, and we're in volume production now. And I'll show you more about that in just a second. The world's first CPO Spectrum X switch. This is also in full production. Co-packaged optics. Optics comes directly onto this chip.
He mentioned
Interfaces
optics.
directly to
Expect the
silicon.
optics market
Electrons get
to start to
translated
rip off the back of
photons,
that.
and it gets
Seriously.
directly connected to this chip. We invented the process technology with
Photonics,
TSMC.
optics,
We're the only
big
one
part
in
of all of
production
this
with it
going
today.
forward.
It's called CUDA. It's completely revolutionary. Nvidia is in full production with Spectrum X. This is the Vera system, twice the performance per watt of any CPUs in the world today. It is also in production. Well, you know, we never thought we would be selling CPUs standalone. We are selling a lot of CPUs standalone. This is already, for sure, going to be a multi-billion-dollar business for us. So I'm very, very pleased with our CPU architects. We've designed a revolutionary CPU. And this is the CX9 powered with Vera CPU, the Bluefield 4 STX, our new storage platform. Okay, so these are the racks, and it's connected. Each one of these racks, the NVLink rack, this is, I've shown you guys this before, it's a super heavy. It seems to get heavier every year because I think there's just more cables in there every year. And so
It's a big
this
harmonica.
is the NVLink rack. We've also taken this technology because
it's a server rack.
it is so efficient to create a data center with these cabling systems, structured cables. So we decided to do that for Ethernet. So this is Ethernet, 256 liquid-cooled nodes in one rack, and it is also connected with these incredible connectors. You guys want to see Rubin Ultra?
Sure. Can he hold it? Can he lift it? Ah, look at that. It's like he's got the force. Amazing.
So this is the Rubin Ultra compute node. Unlike Rubin that slides in horizontally, Rubin Ultra goes into a whole new rack. It's called Kyber, that enables us to connect 144 GPUs in one NVLink domain. And so the Kyber rack, this, I could lift it, I'm sure, but I won't. It's quite heavy. This is one compute node, and it slides into the Kyber rack vertically. This is where it connects into. This is the mid-plane.
Is that what he meant by
The Kyber
horizontally
racks,
and vertically integrated?
those
Maybe?
4 top NVLink connectors slide in and connect into this, and this becomes one of the nodes. And each one of these racks is a different compute node, and this is the amazing part. This is the midplane, and the back of the midplane, instead of the cabling system, which has its limits in terms of how far we
No
can drive
cables,
cables,
just plug and
copper
play.
cables, we now have this system to connect 144 GPUs. This is the new NVLink. This sits also vertically, and it connects into the midplanes on the back. Compute in the front, NVLink switches in the back.
They should call it the Nvidia
one
mullet.
giant computer. Okay, so that
Style at the
is
front, party at the back.
Rubin Ultra.
I like
As
Nvidia
I
mullet.
mentioned,
That's
as
pretty
I
good
mentioned,
idea.
how about we take this back down? I need the rest of my slides. Oh, it's coming down? Okay. Thank you, Janine. This is what happens when you don't practice.
Oh, he's practiced this. Give me a break.
Okay, all right, so take your time, just don't get hurt. You saw this slide. You know, only at NVIDIA's keynote will you see last year's slide presented again. And the reason for that is I just want to let you know that last year I told you something very, very important. And it's so important, it's worthwhile to tell you again. This is probably the single most important chart for the future of AI factories. And every CEO in the world will be tracking it, will be studying it very deeply. It's much, much more complicated than this. It's multi-dimensional. But you will be studying the throughput and the token speed of your AI factories. The throughput, token speed at ISO power, because that's all the power you have, throughput and token speed for your factories forever. And that analysis is going to lead directly to your revenues. What you do this year will show up precisely next year as your revenues. And this chart is what it's all about. And I said on the vertical axis, thank you guys. On the vertical axis is throughput. On the horizontal axis is token rate. Today, I'm going to show you this. Because we're now able to increase the token speed, and because model sizes are increasing, because the token length, the context length, depending on the different
Okay, this one's a little bit more interesting.
Application use case,
Let's see where he goes with this.
Continues to grow from maybe 100,000 tokens input length to maybe millions. The token input length is growing, and also the output token length is growing. And so all of these play into, ultimately, the marketing and the pricing of future tokens. Tokens are the new commodity, and like all commodities, once it reaches an inflection, once it becomes mature or becomes maturing, it will segment into different parts. The high throughput, low speed could be used for the free tier. The next tier could be the medium tier. Larger model maybe, higher speed for sure, larger input context length. That translates to a different price point. You could see from all the different services, this one is free, it's a free tier. The first tier could be $3 per million tokens. The next tier could be $6 per million tokens. You would like to be able to keep pushing this boundary because the larger the model, smarter. The more input token context length, more relevant. The higher the speed, the more you can think and iterate, smarter AI models. So this is about smarter AI models. And when you have smarter AI models, each one of these clicks allows you to increase the price. So this is $45. And maybe one day there'll be a premium model that allows you, a premium service that allows you to generate token speeds that are incredibly high because you're in a critical path, or maybe you're doing really long research, and $150 per million tokens is just not a thing. So let's translate that. Suppose you were to use 50 million tokens per day as a researcher at $150 per million tokens. As it turns out, as a research team, that's not even a thing. So we believe that this is the future. This is where AI wants to go. This is where it is today. It had to start here to establish the value.
I mean, it's a race. It's a race to the bottom on token cost, basically.
In the future, you're going to see most
who can provide the most amount of tokens for the least amount of price with the most amount of speed.
Hopper started, and I moved the chart. This is 50. This is 100. Hopper looks like this, and you would have expected Hopper, the next generation, to be higher, but nobody would have expected it to be that much higher. This is Grace Blackwell. What Grace Blackwell did is, at your free tier, increase your throughput tremendously. However, where you mostly monetize your service, it increased your throughput by 35 times. This is no different than any product that every company makes. The higher the tier, the higher the quality, the higher the performance, the lower the volume, the lower the capacity. And so it is no different than any other business in the world. And so now we're able to increase this tier by 35x. And we introduced a whole new tier. This is the benefit of Grace Blackwell, a huge jump over Hopper. Well, this is what we're doing with. Okay, so this is Grace Blackwell. Okay, let me just reset this. And this is Vera Rubin. Okay? Now just think what just happened. At every single
you can kind of get an idea of where this is heading. You know, think about this time next year, and that Rubin line is where the Blackwell line is, and then there's a new line above the Rubin line, and that just continues on.
Is the hard work. This is incredibly hard to do out here. This is the benefit of NVLink 72. This is the benefit of extremely low latency. This is the benefit of extreme co-design, that we could shift the entire area up. Now, what does it mean from a customer perspective in the end? Suppose I were to take all of that and I just, multiply it against, suppose I took 25% of my power, used it in a free tier, 25% of my power in the medium tier, 25% of my power in the high tier, and 25% of my power in the premium tier.
If we get, as noted in the chat, if we get kicked off and banned by Nvidia,
the free tier allows me to attract more customers.
I mean,
this allows me to serve my most
we'll
valuable
hope not.
customers.
At least
I'm
providing some sort of commentary on this.
Allows you basically your revenues.
Hopefully we don't get kicked off by Nvidia.
Simplistic example.
If we do, I can just switch to me talking and the audio rather than the video stream. Anyway,
Vera Rubin to generate.
Should we be more friendly towards Nvidia? You guys are great. Bye Nvidia GPUs for your data centers, everybody.
So Vera Rubin, you should get there as soon as you can. And the reason for that is because your cost of tokens goes down and your throughput goes up. Now, but we want even more. We want even more. And so let me just show you back to this. This is, as I told you, this throughput requires a ton of flops.
But we are still live, so this is good.
This interactivity requires enormous amount of bandwidth. Computers don't like extreme amount of flops, extreme amount of bandwidth, because there's only so much.
Also worth pointing out, I'm not sure they've bigged up the whole Grock integration as much as it probably means to them in terms of pushing out the speed of tokens per second. Oh no, wait, he just mentioned Grock.
Acquired the team that worked on the Grock chips.
I muted him when he said Grock, but this is the impact that Grock's going to have on them. Watch this.
This is what that looks like. So at the most valuable tier, we're now going to increase performance by 35x. Now, this very simple.
And like I said, next year, that line's just going to get higher. And the year after that, that line's going to get higher again. So, you can expect that free tier to double from there, at least.
Throughput matters so much. NVLink 72 is so game-changing. It is exactly the right architecture, and it's even hard to beat, even as you add Grock to it. However, if you extended this chart way out here and you said you wanted to have services that delivers not 400 tokens per second, but 1,000 tokens per second, all of a sudden, NVLink 72 runs out of steam and it simply can't get there. We just don't have enough bandwidth. And so this is where Grock comes in, and this is what happens when we push that out. So it goes out beyond, thank you. Goes out beyond.
Okay, so that's what I'm talking about. Going past into the thousands of tokens per second. That's inference. That's what inference chips do.
Relative to Blackwell, Vera Rubin is 5x. If most of your workload is high throughput, I would stick with just 100% Vera Rubin. If a lot of your workload wants to be coding and very high valued engineering, token generation, I would add Grock to it. I would add Grock to maybe 25% of my total data center. The rest of my data center is all 100% Vera Rubin. And so that gives you a sense of how you would.
This is now also them trying to get a return on their investment into Grock. As I said, they spent $20 billion.
This is what happens.
Is the sort of figure that's used to get that Grock technology
the reason why Grock was so attractive to me is
into their manufacturing and design processes.
A deterministic data flow processor. It is statically compiled. It is compiler scheduled. Meaning the compiler figures out when the data, when to do the compute and the data arrives at the same time. All of that is done statically in advance and scheduled completely in software. There's no dynamic scheduling. The architecture is designed with massive amounts of SRAM. It is designed just for inference, this one workload. Now, this one workload, as it turns out, is the workload of AI factories. And as the world continues to increase the amount of high-speed tokens it wants to generate with super smart tokens it wants to generate, the value of this integration is going to get even higher. And so these are two extreme processors you could see. One chip, 500 megabytes. One Vera Rubin chip, 288 gigabytes. It would take a lot of Grock chips to be able to hold the parameter size of Rubin, as well as all of the context that has to go, the KV cache that has to go along with it. So that limited Grock's ability to really reach the mainstream, to really take off, until we had a great idea. What if we disaggregated inference altogether
now they're
with
going
a
to
piece of
announce
software
something
called
bigger.
Dynamo? What if we re-architected the way that inference is done in the pipeline?
Saving the goodies till
so
last,
that we
it looks like.
Put the work that makes perfect sense on Vera Rubin, and then offload the decode generation, the low latency, the bandwidth limited, challenged part of the workload for Grock. And so we unified two processors of extreme differences, one for high throughput, one for low latency. It still doesn't change the fact that we need a lot of memory. And so Grock, we're just going to add a whole bunch of Grock chips, which expands the amount of memory it has. And so if you could just imagine, out of a trillion parameter model, we have to store all of that in Grock chips. However, it sits next to NVIDIA Vera Rubin, where we could hold the massive amounts of KV cache that's necessary in processing all of these agentic AI systems. It's based upon this idea of disaggregated inference. We do the prefill, that's the easy part, but we also tightly integrate the decode. So the attention part of decode is done on NVIDIA's Vera Rubin, which needs a lot of math, and the
So unless they announce it
feed
now,
forward
expect
network part of it, the
future
decode part
iterations
is
of this
done,
to just be
the
one
token generation
chip.
part is done on Vera Rubin, on the Grock chip. The two of them working tightly coupled together over today Ethernet with a special mode to reduce its latency by about half. And so that capability allows us to integrate these two systems. We run Dynamo, this incredible operating system for AI factories on top of it, and you get 35 times increase. 35 times increase, not to mention additional new tiers of inference performance for token generation the world's never seen. So this is it. This is Grock. The Vera Rubin systems, including Grock, I want to thank Samsung, who manufactures the Grock LP30 chip for us, and they're cranking as hard as they can. I really appreciate you guys. We're in production with the Grock chip.
Big shout out for Samsung there.
You know, we'll ship it.
That
in
should
the second
see
half, probably about Q3
that should
timeframe.
see the stock price move on the Korean market today.
Grock LPX. Vera Rubin, you know, it's kind of hard to imagine any more customers. You know, and the really great thing is
How
Ray
funny are
Stockwell,
these guys?
early
It's hard to
sampling of it was
imagine
really
we could have
complicated
more
because of
customers than we
coming
already
together
do.
of NVLink 72, but
Love
the
it.
sampling of Vera Rubin is just going incredibly well. And in fact, Satya, I think, texted out already that the first Vera Rubin rack is already up and running at Microsoft Azure. And so I'm super excited for them. We're going to keep cranking these things out. We have now
Jeez,
set
they
up
really
a
like
supply
putting a
chain
lot of companies
that
in
can
really small
manufacture
print on
thousands
the live stream.
a week of these systems, essentially multi-gigawatts of AI factories per month inside our supply chain. And so we're going to crank out these Vera Rubin racks while we're cranking out the GB300 racks. We are in full production. The Vera CPUs, incredibly successful. And the reason for that is because AI needs CPUs for tool use. And Vera CPU was designed just perfectly for that sweet spot. Incredible for the next generation of data
CoreWeave,
processing.
Crusoe,
Vera CPU is
Lambda,
ideal. The Vera
Nebius,
CPU plus plus
lot of
CX9
former
connected into the Bluefield 4
Bitcoin
stack.
miners on there.
100% of the world's storage industry
Iran as well.
is joining us on this system. And the reason for that is because they see exactly the same thing. The storage system is going to get pounded. It's going to get pounded because we used to have humans using the storage systems. We used to have humans using SQL. Now we're going to have AIs using these storage systems. And it's going to store CUDF accelerated storage, QVS accelerated storage, as well as, very importantly, KV caching. Okay, so this is the Vera Rubin system. Now, what's amazing is this. In just 2 years' time, in a 1 gigawatt factory, in just 2 years' time, in 1 gigawatt factory, using the mathematics that I showed you earlier, whereas Moore's law would have given us a couple of steps, we would have, X-factored the number of transistors, we would have X-factored the number of flops, we would have X-factored the amount of bandwidth. But with this architecture, we're going to take our token generation speed, token generation rate from 2 million to 700 million, 350 times increase.
Just a little increase.
This is the power of extreme co-design. This is what I mean when we integrate and optimize vertically, but then we open it horizontally for everybody to enjoy. This is our roadmap. Very quickly, Blackwell is here, the Oberon system. In the case of Rubin, we have the Oberon system. We're always backwards compatible so that if you wanted to not change anything and just keep on moving through with the new architecture, you could
that's a roadmap to just a lot more tokens per second, higher inference, and all those tiers moving up 3, 4, 5x year on year on year on year. It's a bit like Moore's law. It's Huang's law.
Okay, and so there's a lot of conversation about, is NVIDIA going to copper scale up or optical scale up? We're going to do both. So we're going to have NVLink
Definitely going to be more optical than copper.
With Kyber, and then with Oberon, we're going to NVLink 72 plus optical to get to NVLink 576. The next generation of Rubin, with Rubin Ultra, we have the Rubin Ultra chip, which is coming, which is taping out, and we have a brand new chip, LP35. LP35 will, for the first time, incorporate NVIDIA's NVFP4 computing structure. Give you another few X factor speed up. Okay, and so this is Oberon, NVLink 72, optical scale up, and it uses Spectrum 6, the world's first co-packaged optical, and all of this is in production. The next generation from here is Feynman. Feynman has a new GPU, of course. It also has a new LPU, LP40, big step up, incredible new technology. Now, uniting the scale of NVIDIA and the Grock team, building together LP40, it's going to be incredible.
Again, don't underestimate how big a deal that $20 billion they spent on Grock was to their future plans.
Bluefield 5, which connects the next CPU with the next Super NIC, CX10. We will have Kyber, which is copper scale up. We will also have Kyber CPO scale up. So for the first time, we will scale up with both copper.
Again, put this into some sort of context. So that's just a few years of progression for them. Roll that forward another couple of years of progression, and you kind of take that, expand it out, and you start to get a bit of an idea of just how far and how fast they take AI, the speed, tokens, all those sorts of things. The inflection point is very much now, and things are moving very, very quickly.
For copper, we need a lot more capacity for optics. We need a lot more capacity for CPO. And that's the reason why we've been working with all of you to lay the foundation for this level of growth. And so Feynman will have all of that. Let me see if I missed everything. That's it. Every single year, brand new architecture. Very quickly.
To do that like an iPhone cycle is insane.
Nvidia went from a chip company to an AI factory company, or AI infrastructure company, AI computing company, these systems. And now we're building entire AI factories. There's so much power that is squandered in these AI factories. We want to make sure that these AI factories come together, designed in the best possible way. Most of these components never meet each other.
Announcing the Nvidia nuclear reactor.
Now we all know each other, but in the past, we never met each other until the data center. That can't happen. We're building super complex systems. And so we have to meet each other virtually somewhere else. And so we created Omniverse, and the Omniverse DSX world, a platform where all of us can meet and design these gigafactories, gigawatt AI factories virtually in system. We have simulation systems for the racks for mechanical, thermal, electrical, networking. Those simulation systems integrated into all of our ecosystem partners of incredible tools companies. We also operated connected to the grid so that we could interact with each other, send each other information so that we could adjust grid power and data center power accordingly, saving energy. And then inside the data center, using Max-Q so that we could adjust the system dynamically across power and cooling and all of the different technologies we all work on together, so that we leave no power squandered, so that we run at the most optimal rate to deliver enormous amount of token throughput. There's no question in my mind there's a factor of 2 in here. And the factor of 2 at the scale we're talking about is gigantic. We call this the Nvidia DSX platform. And just as all of our platforms, there's the hardware layer, there's the library layer, and there's the ecosystem layer.
CUDA.
Exactly the same way. Let's show it to you.
The greatest infrastructure build-out in history is underway. The world is racing to build chip, system, and AI factories. And every month of delay costs billions in lost revenues. AI factory revenues are equal to tokens per watt.
Don't forget cranes,
so with
concrete,
power constraints,
steel.
Every unused watt is revenue lost.
There's a lot of things that go into
Nvidia DSX
metals.
is an Omniverse digital twin blueprint.
You know, he mentioned copper, he mentioned optics, he's talking about massive server racks, connecting all these things together. You know, they're not built on, you know, virtual systems. They're built with physical metals. These things take real world materials, minerals to even just exist. The construction, the human commitment in terms of labor force to get all these things built. This is massive, and the demand for all this is not slowing down at all. As you can see, it's speeding up. So, you know, when you look at all this stuff, think about what actually goes into creating a server rack like that. You know, the physical metals that are required. This is why the critical metals side of things is something we talk about a lot at Southbank as well, is because all of this has to get built. And that in itself is a massive, massive undertaking.
Cadence Reality for internal, ETAP for electrical, and NVIDIA's network simulator, DSX Air. And virtually commissioned through Procore to ensure accelerated construction time. When the site goes live, the digital twin becomes the operator. AI agents work with DSX Max-Q to dynamically orchestrate infrastructure. Phaedra's agent oversees cooling and electrical systems, sending signals to Max-Q, which continuously optimizes compute throughput and energy efficiency. Emerald AI agents interpret live grid demand and stress signals and adjust power dynamically. With DSX,
just a reminder, if anyone's got any questions, chuck them into the chat now, because I think they're going to wind this thing up pretty soon, and so will I. So if you've got any questions now, make sure you fire them in here for me to answer.
It's incredible, right? Well, Omniverse was designed to hold the world's digital twin, starting from the Earth. And it's going to hold digital twins of all sizes. And so we have just such a great ecosystem of partners. I want to thank all of you. All of these companies are brand new to our world. We didn't know many of you just a couple of years ago. And now we're working so close together to work on and build together the largest computer the world's ever seen, and also to do it at planetary scale. So NVIDIA DSX is our new AI factory.
Did he
platform.
say planetary scale? I wonder why he said planetary scale. Like, maybe there's an alternative.
I'll spend very little time on this.
Off-planetary
However,
scale?
We're going to space. We've already been out in space. Thor is radiation approved, and we're in satellites. You do imaging from satellites. In the future, we'll also build data centers in space. Obviously, very complicated to do so. We're working with our partners on a new computer called Vera Rubin Space One, and it's going to go out to space and start data centers out in space. Now, of course, in space, there's no conduction, there's no convection, there's just radiation. And so we have to figure out how to cool these systems out in space. But we've got lots of great engineers working on it. Let me talk to you about something new.
Geez, they didn't give much attention to that, did they? Yikes.
So
the lobster's back.
Peter Steinberger's here, and he wrote a piece of software. It's called OpenClaw, and I don't know if he realized how successful it's going to be, but the importance is profound. OpenClaw is the #1, it's the most popular open source project.
That red line is not an axis. That's the growth rate, just quietly.
It exceeded what Linux did in 30 years. And it's that important. It is that important. It will do, well, this is all you do, okay? We're announcing our support of it.
Yes, this is a big thing for NVIDIA too.
You simply type this. You type this into a console, and it goes out. It finds OpenClaw. It downloads it. It builds you an AI agent, and then you could tell it whatever else you need to do.
Screenshot that.
Okay, so let's take a look.
I won't talk over this bit. Okay, I'll talk over it a little bit. When I said before about playing around with Claude Code, this is sort of the next level of Claude Code. You know, but free and better. But with its own risks as well. Still, this is pretty cool stuff. When I said you can build anything with these sorts of AI coding systems, this is the sort of demonstration of that. Slightly different, but more or less the same.
An open source project just dropped.
Andre Karpathy has just launched something called Research is a huge deal.
You give an AI agent a task, go to sleep, it runs 100 experiments overnight, keeping what works and killing what doesn't.
I really love what my stuff enables that person to do. And we had like one guy, he told me like he installed it at his 60-year-old dad, and like they made beer, connected the machine via Bluetooth to OpenClaw, and then we automated everything, including the whole website for people to order.
Lobsterlager fertig sein.
Had to be German, didn't he?
Hundreds of people are queuing up for lobsters in Shenzhen.
OpenClaw.
We want to build OpenClaw with OpenClaw.
Everyone is talking about OpenClaw, but
For what it's worth, OpenAI bought
Believe it or not, there's already a claw con.
which was phenomenal. First single person $1 billion plus purchase.
Incredible, incredible. Now, I illustrated effectively what OpenClaw is in this way, and so that all of you can understand it, but let's just think what happened. What is OpenClaw? It connects, it's an agentic system. It calls and connects to large language models. So the first thing it has resources that it manages. It could access tools, it could access file systems, it could access large language models. It's able to do scheduling. It's able to do cron jobs. It's able to decompose a prompt that you gave it into step by step by step. It could spawn off and call upon other sub-agents. It has I/O. You could talk to it in any modality you want. You could wave at it and it understands you. You could talk to any modality you want.
You can get it to actually talk back to you when you connect it to speakers and give it a voice.
What else does it have? Well, based on that, you could say, in fact, it's an operating system. I've just used the same syntax that I would describe an operating system. OpenClaw has open sourced essentially the operating system of
now owned by OpenAI.
It is no different than how Windows made it possible for us to create personal computers. Now OpenClaw has made it possible for us to create personal agents. The implication is incredible. The implication is incredible. First of all, the adoption says something, all in itself. However, the most important thing is this. Every single company now realize, every single company, every single software company, every single technology company, for the CEOs, the question is, what's your OpenClaw strategy? Just as we need to all have a Linux strategy, we all needed to have an HTTP, HTML strategy, which started the internet. We all needed to have a Kubernetes strategy, which made it possible for mobile cloud to happen. Every company in the world today needs to have an OpenClaw strategy, an agentic system strategy. This is the new computer. Now, this is just the exciting part. This is enterprise IT before OpenClaw. And I mentioned earlier.
Now it's just a bunch of Mac Minis running agentic OpenClaw systems.
The reason why it's called data centers is because these large rooms, these large buildings, held data, held the files of people, the structured data of business. It would pass through software that has tools and systems of records and all kinds of workflow that's codified into it, and that turns into tools that humans would use. Digital workers would use. That is the old IT industry. Software companies creating tools, saving files, and of course, GSI's consultants that help companies figure out how to use these tools and integrate these tools. These tools are incredibly valuable for governance and security and privacy and compliance, and all of that continues to be true. It's just that post-OpenClaw, post-agentic, this is what it's going to look like. This is the extraordinary part. Every single IT company, every SaaS company will become a
tokens.
Gas company. No question about it. Every single SaaS company will become a gas company, an agentic as a service company. And what's amazing is this, OpenClaw gave the industry exactly what it needed at exactly the time. Just as Linux gave the industry exactly what it needed at exactly the time, just as Kubernetes showed up at exactly the right time, just as HTML showed up. It made it possible for the entire industry to grab onto this open source stack and go do something with it. There's just one catch. Agentic systems in the corporate network can have access to sensitive information, it can execute code, and it can communicate externally.
It's kind of why Amazon servers went down when they unleashed AI into their own systems.
Communicate externally. You could, of course, access employee information, access supply chain, access finance information, sensitive information, and send it out, communicate externally. Obviously, this can't possibly be allowed.
I'm guessing they've got a solution for this.
Was we worked with Peter, we took some of the world's best security and computing experts, and we worked with Peter to make OpenClaw, enterprise secure and enterprise private capable. And we call that, this is our NVIDIA OpenClaw reference for NemoClaw, which is a reference for OpenClaw, and it has all these agentic AI toolkits, and the first part of it is technology we call OpenShell that has now been integrated into OpenClaw. Now it's enterprise ready. This stack
it's almost as complicated as his first slide
with
from
a
earlier
reference
on.
Stack we call NemoClaw. You could download it, play with it, and you could connect to it the policy engine of all of the SaaS companies in the world. And your policy engines are super important, super valuable. So the policy engines could be connected. NemoClaw or OpenClaw with OpenShell would be able to execute that policy engine. It has a network guardrail. It has a privacy router, and as a result,
I feel like even he's bored about talking about this now.
And keep the claws from executing inside our company and do it safely. We also
probably could have cut this segment down by about 10 minutes, Jensen.
System. And one of the most important things you want to do with your own custom claws is so that you can have your custom models. And this is NVIDIA's Open Model Initiative. We are now at the frontier of every single domain of AI models. Whether it's Nemotron, Cosmos World Foundation model, Groot, artificial general robotics, humanoid robotics models, AlphaMyo for autonomous vehicle, BioNemo for digital biology, Earth-2 for AI physics. We are at the frontier on every single one. Take a look.
The world is diverse.
So they're back to these cutscenes again because I think they lost the crowd for a while there. The OpenClaw integration is... I'm not quite sure what to make of that yet. Obviously, they want to roll it out with the enterprise version. But we'll see. Anyone can go get OpenClaw. It's, as you said, open source. You wouldn't probably want to install it on a computer where you've got, a whole heap of personal information or passwords and logins and things like that. But, if you have an old-ish, still relatively RAM-packed computer, like a Mac Mini, I just happen to have a spare Mac Mini kicking around these days, so I think I'll probably load up OpenClaw onto that, or NemoClaw, or some sort of claw, and have a bit of a play around with it, and see if I can get an agentic agent building stuff. Maybe I like the idea of the guy making beer with it. So we'll see. But as I said, you can play around with Claude Code. OpenAI has Codex. Those are the two best agentic coding systems where you can ask it to build you. I had my son in here the other day. He's 4 years old, and him and I built a video game, a bit like Minecraft. But it was actually a mashup between Minecraft and K-pop Demon Hunters. He's 4, so that's where things are heading.
Our models are valuable to all of you because, number one, it's on the top of the leaderboard. It's world class. But most importantly, It's because we are not going to give up working on it. We're going to keep on working on it every single day. Nemotron 3 is going to be followed by Nemotron 4. Cosmos 1 was followed by Cosmos 2. Groot at Generation 2. Each and one of these, we're going to continue to advance these models. Vertical integration, horizontal openness, so that we can enable everybody to join the AI revolution. Number one on leaderboard across research and voice and world models and artificial general robotics and self-driving cars and reasoning. And of course, one of the most important one, this is Nemotron 3 in OpenClaw. This is Nemotron 3 in OpenClaw. And look at the top 3. There are the 3 best models in the world. Okay, so we are at the frontier. It is also true.
That's
that
it.
we want
Looking forward to
create the
Anthropic's
foundation model so
IPO
that
at
all
some
of you can
stage.
fine-tune it, post-train it into exactly the intelligence you need. This is Nemotron 3 Ultra. It is going to be the best base model the world's ever created. This allows us to help every country build their sovereign AI. And we're working with so many different companies
Not
out
every
there.
country.
And one of the most exciting things that we're doing today, I'm announcing today, is a Nemotron coalition. We are so dedicated to this. We have invested billions of dollars of AI infrastructure so that we could develop the core engines for AI that's necessary for all the libraries of inference and so on, but also to create the AI models to activate every single industry in the world. Large language models is really important. Of course it's important. How could human intelligence not be? However, in different industries around the world, in different countries around the world, you need to have the ability to customize your own models, and the domain of the models is radically different, from biology to physics to self-driving cars to general robotics to, of course, human language. And we have the ability to work with every single region to create their domain-specific, their sovereign AI. Today, we're announcing a coalition to partner with us to make Nemotron 4 even more amazing. And that coalition has some amazing companies in it. Black Forest Labs, imaging company, Cursor, the famous coding company, we use lots of it, LangChain.
It's like NATO for
billion downloads
AI systems.
For creating custom agents, Mistral, the Arthur mentioned, I think he's here, incredible company. Perplexity's computer, absolutely use it. Everybody use it.
That's what I was talking about before,
good.
Perplexity computer.
A multimodal agentic system, Reflection, Sarvam from India, Thinking Machine, Mira Murati's lab. Incredible companies joining us. Thank you. I said that every single enterprise company, every single software company in the world needs an agentic systems, need an agent strategy. You need to have an OpenClaw strategy, and they all agree. And they're all partnering with us to integrate Nemo, the NemoClaw reference design, the Nvidia Agentic AI toolkit, and of course, all of our open
Interesting
models.
to see Atlassian up there
Another.
and
There's
Adobe.
So many. And we're partnering with
Two
all
companies
of you.
that have
I'm
been
really grateful for
absolutely
that.
had their stock price eviscerated
this is
by
our moment. This is a reinvention.
AI
This is a renaissance.
over the last few months.
A renaissance of the enterprise IT. From what would be a $2 trillion industry, this is going to become a multi-trillion-dollar industry, offering not just tools for people to use, but agents that are specialized in very special domains that you're expert in, that we could rent. I could totally imagine in the future, every single engineer in our company will need an annual token budget. They're gonna make a few $100,000 a year, their base pay. I'm gonna give them probably half of that on top of it.
Get paid in
as
tokens.
So that they could be amplified 10x.
I wonder if you can order pizza with tokens.
It is now one of the recruiting
Maybe get an agentic AI to make
Silicon
you a
Valley.
pizza.
How many tokens comes along with my job? And the reason for that is very clear, because every engineer that has access to tokens will be more productive. And those tokens,
The guy renovating my
know,
bathroom at the
will be
moment is
produced
definitely
by
not
AI
asking for
factories
tokens,
that
though.
all of you and us We partner to build, okay? So every single enterprise company in today sit on top of file systems and data centers. Every single software company of the future will be agentic, and they will be token manufacturers. There'll be token users for their engineers, and there'll be token manufacturers for all of their customers. The OpenClaw event,
like people getting mugged in the street for their tokens.
This is as big of a deal as HTML. This is as big of a deal as Linux. We have now a world-class open agentic framework that all of us could use to build our OpenClaw strategy. And we've created a reference design we call NemoClaw, that all of you could use, that is optimized.
Is there going to be a Nemo Cloud where we can all connect remotely to NemoClaw? Definitely. Hey, robots, finally.
Speaking of agents, as you know, perceive, reason, and act. Most of the agents in the world today that I've spoken about are digital agents. They act in the digital world.
Physical agents.
They reason, they write software. It's all digital.
They really don't like sticking to the times either that they allocate for these things.
Physically embodied agents for a long time. We call them robots. And the AIs that they need are physical AIs. We have some big announcements here. I'm going to just walk through a few of them. 110 robots here. Almost every single company in the world, I can't think of one, that are building robots is working with NVIDIA. We have 3 computers: the training computer, the synthetic data generation and simulation computer, and of course the robotics computer that sits inside the robot
Robotics,
itself.
Look, there's
we have all the software stacks necessary to do so. The AI
Hyundai,
models to help you.
Hyundai do robotics and cars.
And all of this is integrated into
those industrial robot companies are crazy.
And all of our partners from Siemens to Cadence, incredible partners everywhere. And today we're announcing a whole bunch of new partners. As you know, we've been working on self-driving cars for a long time. The ChatGPT moment of self-driving cars has arrived. We now know we could successfully, autonomously drive cars. And today
they've been doing this for a decade. This is a decade long, plus more than a decade of self-driving car stuff.
Ready platform. BYD, Hyundai, Nissan, Geely, all together.
Nissan.
18 million cars built each year. Joining our partners from before, Mercedes, Toyota, GM. The number of robo-taxi-ready cars in the future are going to be incredible. And we're announcing also a big partnership with
Elon,
Uber.
You're not the only one.
Multiple cities, we're going to be deploying and connecting these robo-taxi-ready vehicles into their network. And so a whole bunch of new cars. We have ABB, Universal Robotics, KUDA, so many robotics companies here. And we're working with them to implement our physical AI models integrated into simulation systems so that we could deploy into manufacturing lines all over.
You start to see some of these little robotic companies, these humanoid robotic companies. I think we'll start to see a few more of those IPO hit the markets this year and next year too.
Radio tower is going to be an NVIDIA aerial AI RAN. And so this is going to be a robotics radio tower, meaning it can reason about the traffic, figures out how to adjust its beamforming so that it could save as much energy as possible and increase the amount of fidelity as possible. There's so many humanoid robots here, but one of my favorites.
Oh, who's he gonna
is
mention?
a Disney robot.
Here we go.
You know what?
He does this every year now.
Let me just show you some of the videos. Let's look at that first.
He does this every year. He shows all these robots, has all the cool stuff on screen, and then just brings out the little Wall-E robot that the Disney Imagination Studios or whatever has been working on. Cutscenes. So I'm not quite sure where they're heading with this now. I mean, we knew they were going to talk about robots at some stage. So yeah.
Explain its thinking as it makes decisions.
There's a double parked vehicle in my lane. I'm going around it.
And follow instructions.
I couldn't think of anything worse than my car telling me about every single thing it wanted to do on the road. Oh, God.
This is the age of physical.
Unless it starts swearing at other drivers, then that'll make it more human.
Building robots of every kind. But the real world is massively diverse, unpredictable, full of edge cases. Real-world data will never be enough to train for every scenario. We need data generated from AI and simulation. For robots, compute is data. Developers pre-train world foundation models on internet-scale video.
So this actually, that reminds me, it's pretty funny about the Pokemon. I don't know if everyone's seen the Pokemon Go story that's come up about how Niantic, the company that made Pokemon Go, with everyone walking around with their smartphones with augmented reality Pokemon out in the world. Well, apparently what that did was just record billions and billions and billions of images. There's like 30 billion something images for Niantic to then take and hoard that data in order to build basically the most centimeter perfect model of the world for their autonomous robots to now deploy. So that whole Pokemon Go thing was just a way for Niantic to capture one of the greatest visual data sets of all time. Well done, Niantic.
Trains their operating room assistant robot in Nvidia Isaac Lab, multiplying their data with Nvidia Cosmos world models. Skilled AI uses Isaac Lab and Cosmos to generate post-training data for their skilled AI brain. They use reinforcement learning to harden the model across thousands of variations. Humanoid uses Isaac Lab to train whole body control and manipulation policies. Hexagon Robotics uses Isaac Lab for training and data generation. Foxconn fine-tunes group models in Isaac Lab, as does Noble Machines. Disney Research uses their Camino physics simulator in Newton and Isaac Lab to train policies across their character robots in every universe.
He's going to come out on stage now. Maybe it's this guy. Disney's going to have something coming out on stage in a minute. It'd be good if it was like a Mickey Mouse thing. Kids these days, they don't know the real Disney. Kids these days. God, I can't believe I just said that. He's definitely coming out on stage, isn't he? Yep, there he is.
Ladies and gentlemen, Olaf.
That is pretty cool, to be fair.
Coming through.
Newton works.
Wow.
Omniverse works. Olaf.
Unless it's a kid inside it.
I'm so happy now that I'm meeting you.
I know. Because I gave you your computer. Jetson.
Like those Chinese robot demonstrations from days gone by where there was just people in, like, spandex.
Inside Omniverse.
I love walking. This is so much better than riding on a reindeer gazing up at a beautiful sky.
And it was because of physics, using this Newton solver that runs on top of NVIDIA Warp that we jointly developed with Disney and with DeepMind that made it possible for you to be able to adapt to the physical world. Check that out. That's how smart you are.
Yeah, well, this isn't awkward at all, is it?
Not a snowclopedia.
Could you imagine this? The future of Disneyland? All these robots, all these characters wandering around.
Oh.
You know, I have to admit though,
I mean,
I thought
it's
you were
good. But is it as good as like those old pizza restaurants with the animatronic band up the front that kind of put the living fear into you while you were eating pizza, but was also kind of cool? Is it any different to that? 25, 30 years later?
Usually I close the keynote by telling you what I told you. We talked about inference, inflection. We talked about the AI factory. We talked about the OpenClaw agent revolution that's
Jensen
happening.
here
And
does a rendition of Let It Go, that would be quite the ending to this keynote.
Why don't we get some friends to help us close it out?
Oh my God, he might actually do that.
All right, play it.
Come on. Terminating simulation.
Hello?
Is this going to be like the Chinese robot demonstration where they were doing flips and basically karate kicking each other for a while? Could be. Looks like it. Maybe. Don't know where they're going with this. But it's pretty cheesy so far.
The keynote's over, all was said. Jensen mapped the road ahead. AI factories coming alive. Agents learning.
Okay, so this bit kind of sucks because it's, unless they get these robots on stage in the next 2 minutes, there's not much more to get excited about here, I don't think. I mean, this is a recap. You can see what they're saying there. I got to turn this down. It's actually quite distracting now. So the inference stuff's really cool. The Grock integration into their chips is certainly going to be something to keep an eye on. The stock market loved it when he said trillions, and then when he didn't keep saying trillions, the stock price gave up all its gains for the day and finished absolutely where it started, which is pretty funny. That was a pretty good keynote from a technical side of things. There wasn't a lot of flash around robotics and automated stuff. There was a fair bit there on OpenClaw and the integration of that, which is interesting. I would expect to see that maybe at the next major keynote, the integration of NemoClaw into something like DGX Spark, which will be their AI personal computer, which they didn't talk about that stuff at all, which is also interesting. But Inference, the way they're integrating Grock and the push they're making with the next generation Feynman of their servers and their GPU connectivity is big. The speed, yearly cycles now for this stuff, which is, the complexity of these systems is hard to fathom, but the fact that they're now upgrading them at such a leap year on year on year says a lot, because you roll forward 3, 4, 5 years time, and where they will be at is pretty hard to fathom, and that's just going to compound over the next couple of years. So decent keynote. Olaf at the end was just wonderful, and this little cutscene is pretty crappy way to end the whole thing, to be honest with you. I don't think they're going to come back with anything else. So frankly, I'm going to have a look at how many people are actually left watching this watch along. There's still a few of you there, so I'll kick on a little bit longer. But if you wanted to jump off now, feel free. If you got any questions, you can chuck them quickly in the chat now. Otherwise, write into us at Southbank Research. You can jump onto our website, www.investorsdaily.co.uk. Make sure you subscribe to our e-letter, where I will be writing about a lot of this and a lot more of this, because it's very important stuff. Nvidia is now wrapping up. He's saying goodbye. And I am also going to wave and say goodbye. Everybody. And thank you. Thanks for tuning in. That was interesting. That was fun to couple of hours. Yeah, we'll maybe do another live stream another time for something important and major like this. But until then, thanks for watching, and I'll be with you again another time. Bye for now.